faster than the very essence of spacetime, it holds the power to remain aware of it. As a result, this awareness will slowly unravel this concept, causing a mounting discomfort within me. At this precise moment, the night sky above us is rapidly changing, and within the next few decades, perhaps even sooner, it may become completely unrecognizable. Leading experts, including Neil deGrasse Tyson, have raised concerns, acknowledging the unavoidable transformations caused by the shifting position of Polaris. The underlying reasons behind this occurrence are quite unexpected. Polaris, commonly known as the North Star, has been a reliable fixture in the sky for thousands of years, serving as a vital point of reference for astronomers, navigators, and stargazers. However, this may soon change, altering our perception of the heavens and the way we explore the universe. Let's take a closer look at the possible implications of this shift. For centuries, Polaris has been a beacon of guidance for sailors and astronomers, maintaining a stable position in the sky. This consistency has been essential for navigation, but this equilibrium might soon be disrupted. A study published by the esteemed Royal Astronomical Society in September 2023 raised concerns about the future of this celestial marker. Polaris is entering a turbulent phase, one in which it might eventually explode and vanish from view, drastically altering the sky we know. Before considering the potential outcomes of such an event, let's explore the characteristics of the star itself. Polaris is notable for its location near the celestial North Pole, positioned directly above Earth's northernmost point. It appears almost stationary in the sky and is part of the Ursa Minor constellation, often referred to as the Little Dipper. Polaris shines with moderate brightness and is classified as a yellow-white supergiant, significantly larger and brighter than our Sun. However, Polaris is not a single star but part of a triple star system that includes Polaris A and Polaris B as a binary pair, along with a third star orbiting them. The gravitational interactions between these stars affect their orbits and behavior, and any disruptions in these interactions could cause fluctuations in their brightness or pulsation patterns. Despite this, the precise nature of these forces remains uncertain. Polaris is located about 323 light-years away from Earth, meaning the light we see from it today began its journey a long time ago. If Polaris were to explode, the effects wouldn't be visible to us for over 300 years. It's possible that Polaris has already exploded, but we simply haven't observed it yet. Throughout history, the North Star has held immense cultural, navigational, and symbolic significance. Its unchanging position in the sky has made it an invaluable guide for ancient sailors traveling vast oceans and lands. Symbolically, Polaris has come to represent constancy and direction, remaining a fixed point in the ever-shifting heavens. For astronomers, Polaris has served as a crucial reference for studying stellar movements and variable stars. As a variable star, its periodic changes in brightness have provided essential insights into the properties and behavior of stars. This characteristic has also been key in measuring cosmic distances and calibrating scientific instruments, as its pulsations follow a predictable rhythm. Recently, however, Polaris has begun showing signs of straying from its typical behavior. This irregularity in its pulsation cycle has caught the attention of astronomers, prompting further research into the causes of these unexpected shifts. Instead of maintaining its usual rhythm, Polaris has shown erratic dimming, raising concerns that the star may be nearing the end of its life cycle. This behavior mirrors patterns seen in stars approaching their final stages. The gradual lengthening of Polaris's pulsation period, which was once stable, has been observed over the past year, with an increase of approximately 4.5 seconds annually. Though this change might seem minimal, it carries substantial implications. Some astronomers suggest that gravitational forces between the stars in the Polaris system might be driving these changes, directly affecting the star's atmospheric conditions and pulsation patterns. Others worry that Polaris is entering a critical phase, potentially leading to an explosion. The similarities between Polaris's behavior and that of Betelgeuse, a prominent star in the Orion constellation, are striking. Both stars have exhibited complex variations in brightness, leading to concerns that they may be on the verge of a catastrophic explosion. Stars nearing the end of their life cycles often show such irregularities before their demise. NASA has expressed more concern about Betelgeuse, but formal attention has yet to focus on Polaris. When a variable star reaches the end of its life, it goes through several stages, including the red giant phase, ultimately culminating in a supernova explosion. Given the irregular pulsations observed in Polaris, scientists speculate that it may have entered the helium exhaustion phase, a common trait for giant stars nearing the end of their lives. While these anomalies align with patterns observed in other stars nearing their final stages, there is still no definitive evidence pointing to an impending supernova, and astronomers are continuing to monitor these irregularities to better understand Polaris's future. If Polaris were to undergo a supernova or a similar explosion, it would be a spectacular event in the sky, potentially outshining the moon and remaining visible for days, weeks, or even months. Its brilliance could drastically change our view of key constellations like the Big Dipper or Ursa Major, in which Polaris plays a crucial role. Fortunately, Earth would likely remain unaffected by the explosion, thanks to the vast distance between us and the star. Although the explosion of Polaris might not be as visually striking as Betelgeuse's potential supernova, it would still be visible to the naked eye for a prolonged period, possibly outshining neighboring stars. This would undoubtedly capture the attention of astronomers and stargazers, sparking widespread interest both in the academic world and among the general public. However, any effects on Earth's environment or ecosystems would likely be minimal compared to a supernova occurring closer to our planet. Now, let's consider what will happen to Polaris itself. What is its future after a possible supernova event? It's important to recognize that, although massive stars typically end their lives in a supernova, this is unlikely for Polaris. When a large star undergoes a supernova, its core collapses, triggering a violent shockwave that causes the star to disintegrate. However, Polaris isn't massive enough to undergo such a violent event. Instead, once it exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This process won't result in a supernova but will mark a quieter conclusion, as Polaris evolves into a dense stellar remnant. A white dwarf is the compact core of a low to medium mass star that has exhausted its nuclear fuel. Despite its small size, roughly equivalent to that of Earth, a white dwarf still retains the mass of the Sun. Once this transformation takes place, Polaris will no longer appear as we know it. By comparing the potential explosion of Polaris to actual supernova events, scientists can gain valuable insights into stellar evolution and the ultimate fates of stars. For instance, supernova events like SN 1987A, SN 2011FA, and SN 2014J have provided crucial data that help us understand the processes behind these stellar phenomena. SN 1354, for example, led to the creation of the Crab Nebula, a cloud of material that continues to expand and emit energy across various wavelengths, offering a rich field of study for astronomers. Moreover, SN 1987A, observed in the Large Magellanic Cloud, provided essential insights into nucleosynthesis and the mechanics of supernova remnants, such as nebula formation and the release of high-energy radiation. These discoveries are helping us understand the unique characteristics of Polaris. The formation of nebulae like the Crab Nebula occurs when the material ejected during a supernova explosion interacts with surrounding interstellar gas and dust. This process enriches the gas with heavier elements, contributing to the ongoing cycle of star birth and death. The release of high-energy particles and shockwaves from supernovae also has significant implications for astrophysical processes and cosmic radiation. To make a direct comparison, scientists are studying the differences in the production and speed of ejected material between potential explosions of Polaris and other observed supernovae. By analyzing light curves, spectra, and remnants from these events, astronomers can predict how the explosion of Polaris might impact the formation of nebulae or affect stellar distributions in important ways. Another area of study involves the pulsational variability of stars approaching the end of their life cycles. By comparing Polaris to other supernova progenitors, astronomers hope to gain a deeper understanding of the mechanisms behind star explosions. The variation in pulsations of stars nearing their end may indicate internal instability or an impending catastrophic event, offering valuable insights into the processes that lead to supernovae. Despite the detailed observations and ongoing research, Experts in the field of space remain puzzled by the irregularities in Polaris's behavior. Understanding the causes behind these anomalies is essential for advancing our knowledge of stellar evolution. Investigating the factors responsible for Polaris's erratic pulsations requires collaboration across scientific disciplines, along with the development of advanced models and observational techniques. The possible loss of Polaris as a celestial reference point raises fundamental questions for astronomical research. Ground-based telescopes and measurements of celestial distances would need to be recalibrated, which could affect the accuracy of cosmic measurements. The disappearance of Polaris would also disrupt navigation systems and cultural practices that rely on celestial markers. This highlights the importance of such an event. The mysterious behavior of Polaris underscores the urgent need for further studies and focused research. Astronomers must address the complexities surrounding its irregular pulsations and provide meaningful answers to determine the star's future. The disappearance of Polaris would have profound implications for various fields of study and cultural practices. One significant consequence would be the need to recalibrate astronomical tools and methods. Polaris has long been a reliable reference point for measuring distances in the cosmos, and its vanishing would disrupt current models of the universe. Astronomers have relied on its predictable behavior for centuries to map the cosmos, and without it, other methods of measurement would need to be developed, which could take years of study and adjustment. Additionally, Polaris has played a critical role in navigation, particularly for sailors and travelers. Its steady position in the sky has helped guide explorers across vast oceans and unfamiliar lands. If Polaris were to vanish, it would create significant challenges for modern navigation systems still relying on celestial bodies for orientation. This would be especially problematic in remote areas where electronic navigation aids might not be as effective or accessible. Besides practical concerns, the cultural importance of Polaris cannot be overlooked. For many ancient civilizations, the North Star symbolized constancy and direction, offering a sense of stability in an otherwise chaotic world. Its disappearance would likely have profound emotional and psychological effects on various communities, especially those who have long associated the star with guidance and hope. Even today, many cultures continue to view Polaris as a symbol of unchanging steadiness in the face of life's uncertainties. The potential fading of Polaris also highlights the dynamic, ever-changing nature of the universe. Stars like Polaris undergo various stages throughout their lifetimes, and their eventual death is just part of the natural cosmic cycle. While the thought of losing such a prominent and dependable star may seem unsettling, it serves as a reminder of the vast, complex processes happening in the universe beyond our understanding. As new stars are born and old ones die, the heavens above us continue to shift and evolve. As we study the stars and their behavior, changes in Polaris's pulsation patterns will likely provide astronomers with additional insights into the life cycles of stars and the forces that govern their existence. This knowledge could help scientists better understand the broader processes behind the formation, evolution, and death of stars. By investigating how stars like Polaris behave as they near the end of their lives, we can gain important insights into the mysteries of stellar evolution and the ongoing transformation of the universe. Despite the uncertainty surrounding the fate of Polaris, one thing remains clear. It has been an invaluable resource for astronomers, navigators, and cultural traditions for centuries. Whether it eventually transforms into a white dwarf or undergoes another unexpected phase, its eventual disappearance will mark the end of an era in our understanding of the cosmos. However, as we've seen with other celestial events, new stars and discoveries will continue to emerge, providing humanity with fresh insights into the nature of the universe. While the changes occurring with Polaris may seem concerning, they also present a unique opportunity for scientists to explore the fundamental principles of stellar life cycles and the cosmic forces that shape them. The future of Polaris is still uncertain, but the journey to understand its eventual fate promises exciting breakthroughs in our understanding of the universe and the forces that govern it.